Okay, so data tier. Performance problems in this tier are often because of database schema and/or queries. In terms of the database schema, make sure that every table in your database has a primary key and there are relationships between these tables. You should also use indexes on columns that you use for filtering records in your queries. Now you may think this is just stupid, but believe it or not, I've seen databases without primary keys and relationships. And this was actually only a few months ago, not 15 years ago. Now, in terms of our application, because we're using Entity Framework code first, our migrations automatically add the primary key and indexes in our tables. So we don't have to worry about it for the most part. And this advice applies if you're working with a legacy database. So your first point in optimization should be to fix these issues in your database schema. Another schema-related issue I've seen in my career is the implementation of a pattern called EAV, which stands for Entity Attribute Value. So instead of having concrete tables like movies, customers, rentals, our database has only a handful of tables called entities, attributes, and values, and potentially a few other supporting tables. People who like this kind of schema argue that with this, no matter how many classes we have in the application's domain model, we don't have to change the database schema, because everything can be modeled in a generic way using entities, attributes, and values. While this argument is technically correct, there is a huge cost with this approach. First of all, you cannot use any object relational mappers like Entity Framework, and you have to write all your queries by hand. And these queries can easily grow to several hundreds or even thousands of lines. Now, on top of all these ugly, super ugly queries, you'll have huge performance problems. Some queries may take easily half a minute to run. So please, please, please stay away from this pattern. Just because someone came up with a pattern and gave it a name doesn't mean you should use it. So, first you get your database schema right, next comes your queries. How you write a query can have a significant impact on its performance. In our Vidly application, we don't write queries by hand, at least we haven't so far. So all queries are generated by Entity Framework. And in a lot of cases, these queries are fine. But in certain situations, if you look at the query that Entity Framework generates behind the scene, you're not going to sleep at night. It's going to be extremely complex. We'll get to this later in this section. So it's good to keep an eye on queries that Entity Framework runs on your database. If these queries are too complex, it's better to create a stored procedure and write an optimized query to get the same result. And there's absolutely nothing wrong about this. Every tool has strengths and weaknesses. Entity Framework is great in the sense that it saves us from writing all these queries and mapping the results back and forth to our domain objects, but it fails in complex queries. That's when we use stored procedures for optimization. Also, in SQL Server, we have this feature called Execution Plan, which shows you how SQL Server executes your query. Now, this really belongs to a SQL Server course, not here, but I'm just giving you direction. So by using this execution plan, you can see what parts of your query have the biggest cost, and then you can optimize the query by rewriting it. Or you may also want to add additional indexes in your database. Now, what if you have done everything you could do to optimize your queries and they're still slow? Then you may want to consider creating a separate database for your queries. There are architectural patterns like CQRS or command query responsibility segregation that guide you in that direction. So because we read data more often than we modify it, we can create a separate database optimized for reading data. In that database, we pre-join some of our tables to speed up the queries, because joining tables is one of the areas that impacts the performance of a query. But just remember, this approach comes with the cost of maintaining two databases in sync. Otherwise, you're going to get a lot of calls from end users every minute telling you that they have added a new record, but it's not showing up. So unless you have got the right skills and the tools in your team, I would advise you not to go down that path. Another approach is to use caching, as we call it here in Australia, or caching, as is pronounced in the United States. So with caching, we run a slow query and then store the results in the memory. The subsequent requests will be served from this cache in the memory. We'll look at caching later in this section.